What is differentiation? You'll likely know differentiation already from when you used to have to draw tangents to curves at specific points, and it was primarily guesswork. You might have gotten something close, but never an exact answer. Differentiation enables you to calculate it precisely by considering the gradient between 2 points with an infinitesimally small distance between them. To do this, let's remind ourselves of the gradient formula. The change in y divided by the change in x. Now we'll rewrite this formula slightly differently. We'll call the first coordinate x and f of x, and the second coordinate x plus h and f of x plus h. Substituting these into the gradient formula gives f of x plus h minus f of x, all divided by h. This setup is useful because h represents the small distance between the 2 points. By changing h, we can control how close the points are. For differentiation, we want the most exact form of the gradient, so we let h get as close to 0 as possible. However, setting h to 0 would cause division by 0, which we cannot do. To resolve this, we use the concept of a limit, written as the limit as h tends to 0. This allows us to calculate the gradient without breaking mathematical laws. This is the definition of differentiation, often called differentiation from first principles. For example, let's differentiate f of x equals x squared from first principles. Start with the formula. Substitute f of x plus h as x plus h squared. For f of x equals x squared. The formula becomes x plus h squared minus x squared, all divided by h. Expand the numerator to get x squared plus 2xh plus h squared minus x squared. Cancel out the x squared terms. Simplify by dividing each term by h. Finally, take the limit as h tends to 0, which gives 2x. So the derivative of x squared is 2x. Now, is there a quicker way to do this? Let's take a generic term, x to the power of n. Using the same approach, we substitute f of x plus h into the formula and expand x plus h to the power of n, using the binomial expansion. When we simplify, the xn terms and the terms involving h cancel out as h tends to 0, leaving n times x to the power of n minus 1. This is called the power rule. To differentiate, multiply by the current power, then subtract 1 from the power. For example, if f of x equals x squared, the derivative is 2x. If f of x equals 2 times x to the power of 4, the derivative is 8x to the power of 3.